So my name is Jeremy Schulman. I will tell you a little bit about me, but this deck is maybe 6 slides. I'm going to spend some time showing you a demo, a live demo, and then I'll have some more slides after the demo, and hopefully there'll be some time for Q&A. I like to do interactive kind of stuff, so if people do, want to interrupt and have a question that's like burning in your mind, that's cool, but if you can wait to the end, that'd be great. About me, I am a software engineer. That's how I identify as a software engineer, but I've been in the networking industry for over 20 years, always on the vendor side. So I would say I'm a software engineer, but I'm competent in networking. I could take any network set of instructions and actually understand and do things with them, but I'm by no means a network engineer. I've never run a global network. That's kind of its own art and science in my mind. You guys are a special breed in that way. In 2012, I had a very unique opportunity that opened my eyes to what now people are talking about as DevOps and DevOps for networking. But I happened to be at Juniper at the time, and now I'm back, where I wrote the Puppet agent that ran on a switch. Right? So I had to literally write a Ruby stack for netconf because that's how Junos talks, and then I wrote a Puppet agent with the help from Puppet Labs to do this. And it really opened my eyes to what is now in everybody's head about how do we automate the network. But this is back in 2012 when I saw this happen. And so I spent a lot of time building libraries. So how many of you are Juniper customers? And how many of you are also Python programmers? And how many of you are using Junos PyEZ? Yeah, I wrote that. And so Juniper has been doing a great job keeping it up and supporting the community behind it. So again, quick hands again, Python programmers. Do you identify as developers, or you believe, I write Python code, but I'm a network engineer? It's okay. Okay, that's cool. I mean, so 2 years ago, I was in Mountain View where we did a DevOps for Networking Summit, and there was 120 people, and only 5 people raised their hands at that point in time. So it's actually really nice to see a lot more people getting interested in this space. I've had other roles. I do a lot of stuff in the open source. I'll share these slides. You can Google my name and you'll find stuff. I like to be pretty active. My new role at Juniper is actually being a mentor to new college graduates. So I've come back to Juniper to teach these young kids coming out of college how to do network automation or build networking tools in a way that I think is a fun and interactive way with customers. So I work in the field. I'm not part of the business unit. I work in the field. So any of you guys that are Juniper customers and you want to talk with me more about that, I want to take my new kids on field trips. So that'd be cool. All right. But this deck is my own deck, actually. I just joined Juniper like literally last Monday. So anything I say isn't Juniper stuff. This is just me. All right, so there's been a lot of talk in the industry about how network engineers need to become Python developers, and I think that's crap. What I believe is that network engineers need to competently use Python to achieve a singular goal, which is to increase the reliability in your network operations. That's it, right? If you're saying, well, why should I automate my network, or what am I supposed to be doing? What does automation mean to me? This is a very simple way to answer that question. Are you doing something that increases the reliability in your network operations? And if the answer is no, which it probably isn't, you're probably is to what degree that answer is. So always think about it in this way. We don't do automation for the network just for the sake of it. There's a purpose. There's a business reason you're going to do it. And the reason isn't because your management thinks you want to sleep at night or have a personal life or you're going to work less. No, they want a reliable network because their business runs on it. Does that make sense to you guys? All right, good. All right. So in this agenda, I'm going to really talk about what I believe that network engineers should go on this journey about how to use Python, because if nobody really kind of gives you a path to follow and guardrails along it, you're not really sure what to do, where to get started, what makes sense for you. So I'm going to share what I think are good insights, and we can have a lively discussion about it. And then the point of the demo is I want to introduce something called Jupyter Notebooks. Has anybody heard of Jupyter Notebooks? I'm really impressed. How many of you are using them to actively do tasks to automate your network? Sweet, this is great. All right, you can leave. Or you can be that guy in the crowd, that'd be great. All right, so I'm gonna introduce you to this technology and if I say Jupyter or Juniper networks or Juniper notebooks, it's a flip of my tongue. This has nothing to do with Juniper networks. This is a technology that came out of the science and engineering disciplines, I think as a replacement to Mathematica, if anybody knows what Mathematica is. And then we're gonna do a live demo. And this demo is, how can we take LLDP data that we've collected from the network and dynamically draw a network diagram? Because nobody likes to draw the network diagram, so why don't we just take data off the network and just automatically draw it? I'm gonna show you how to do this, and this is something you can go home and do yourself. That is what I believe. All right. Who plays Cards Against Humanity? All right, great. You're gonna like this game then. All right. So managing networks, awesome in theory, kind of a mess in practice. Right, manual via the CLI. You know, we know this is terrible. We want to get away from it. Why? Because it's not reliable, because humans are not reliable. Right? SNMP-based products is a terrible mess for reasons that are technology. I mean, they had a good reason, but they're just really hard to work with. And so nobody really wants to use them, but it's kind of like what most products are today. But trying to integrate SNMP-based products into your environment, I believe, you know, and anybody who's in the Yang, you know, model camp, I will debate this with them heavily, that I'm not sure how the Yang thing is going to be much different than this thing, because enterprise-based MIBs and native-based Yang models to me are kind of the same thing, so maybe they'll get it right this time, I don't know. Vendor products, we can always rip on vendor products, right? Because they've been a dumpster fire of reliability. I mean, you can get some piece of software from a vendor, but it's always been terrible because they generally care about selling you a box. But nowadays, their motivation to sell software is actually much higher, so I'm hoping that vendor products and their quality and their reliability will go up. But historically, it's been a mess. And SDN, I still don't know what people want to use this term for, so we're just gonna kind of not use it anymore. And then people will talk about orchestration systems are gonna save the world, and you know, maybe, but okay, then there's DevOps, so let's make DevOps for networking, and the people who are in DevOps are already having a problem to define what DevOps means to them because the marketing people took over and it's terrible. Okay, then there's everybody who wants to talk about network automation, but nobody knows what it is, or maybe. And then this is obviously my favorite. There are people who will get up on stage and tell you that all network engineers need to be software engineers, and this is an epic fail, and I will argue with them over, you know, any amount of scotch until they submit. So this is the part where I want to talk to you. How does a network engineer begin, and where should they actually stop? Now, this is taken from a research paper from the 1980s by some Berkeley professors on the topic of how does anybody learn a new complex skill. So I didn't make this up. There's a white paper on this. And these are the steps that they define with specificity. What does it mean to be a novice? What does it mean to be competent? What does it mean to be proficient? Somebody, Chris just said in the last thing, well, if you're a proficient Python programmer, he used the word proficient. But I'm going to use these words very specifically, and I'll use it in an analogy because this is the best way I can explain it. How many of you cook? Right, great, okay. So I'm not allowed to cook for reasons that I won't talk about, but I'm allowed to chop and prepare, right? So I'm allowed to dice an onion, right? Or chiffonade, you know, dinosaur kale. But those things, those actions are what a novice learns, like how to dice an onion, how to hold a knife. That's a novice skill because what you're learning is skills out of context. This is, if somebody says dice an onion, you know what to do and you can be pretty good at it. When you're competent, that means you can follow a recipe. So I get plated. I love plated. Plated is great because I get a recipe, I get all the ingredients, and I can actually participate by chopping onions and doing those things. Now, I can get better or worse at being competent in following a recipe, right? And recipes could be easy and recipes could be hard. You know, if I want to make chicken pot pie, the recipe for chicken pot pie I could probably do, but for Chateaubriand, probably not so much, right? Okay. So how does this relate to network engineering? If you're a network engineer, if you can follow a MOP, a method and procedure, a set of instructions, and you can do it reliably, you can competently follow those instructions, right? But when you cross the chasm into being proficient, this is the person who can create the recipe. Like if you gave me a bunch of food items and said, hey, make chicken pot pie, and I had no recipe to follow, you would not be eating chicken pot pie. All right, so there's this giant chasm that you have to cross to become proficient in something. So if you're a network engineer, and when you're competent, you're a network engineer. You've been a network engineer for probably 3 or 4 years, you're competent. But when you cross the chasm into becoming a senior network engineer or an architect, that's when you can, from a blank sheet of paper, create a network design that adheres to some business objective. From a blank sheet of paper, that's your skill, you're proficient in that. But it takes a lot of experience to understand the why you do something to create that architecture or to create that recipe or to write that piece of code. Now what I've learned, or my message here to network engineers who are just getting started is, you should stop at being competent, right? Unless you want to be a software developer. Because once you cross that chasm into being proficient, you're not a network engineer anymore. You are a software developer that has domain knowledge in networking. So some people are starting to use the word network reliability engineer to mean this thing. But if you ask Google what an SRE is, a site reliability engineer, it is a software engineer who builds infrastructure tooling, right? So if some of you want to go on this journey, this is, again, another 5 to 7 year journey to become proficient, right? I'm a software engineer of 20 years, right? It took me 7 or 8 years to be proficient, to write from a blank sheet of paper and create something like Junos PyEZ that would be useful to a broader set of people. This is hard stuff. And then I won't even talk about becoming an expert or master because it's off topic, but it requires a massive amount of time and energy. Okay, how does this relate to networking, right? So networking, to me, I see networking as a complex distributed system. You have all these boxes written by software from different companies over decades of time that are magically going to work together, right? And in this environment, network engineers basically do 2 things. They config stuff, and then they do a bunch of show commands to make sure that whatever they configured or the network is working, they show stuff. So I have this chart where I talk about configuration management and situational awareness. And then I break it down by things that are only done on a device in isolation. I call that host only. So if you're configuring something only on the host, like changing the SNMP community strings, there's little risk in that kind of action. But if you do something that affects the distributed system, like changing routes and route prefixes that can take down the network, that's a high-risk thing, right? Same thing with the situational awareness. If I'm doing a command on a singular device, for example, show IP route to see routes, that's something you can grok and understand. But if you're looking at the entire network as a holistic system to understand, is this service operationally correct? You're going from different boxes to different boxes, running different commands and correlating data in your mind in order to understand, is it correct? This is incredibly complex, incredibly complex. Companies are built around this kind of idea to do all of these things. So when I talk to network engineers about, well, what kind of tasks should they even go after? Start with these very simple situational awareness tasks, really kind of for 2 reasons. One, if it's a read-only option, if you're only doing read-only activity, the risk is low. And if you're trying to do these really complex tasks, then my advice is to buy products that do these complex tasks and learn to automate their API, learn to communicate with their API. So maybe it's OpenStack, or maybe it's some product that's on the market. There's a lot of really great software products that are coming on the market, and they all have APIs. But I would never encourage a network engineer to try to build a complex distributed network monitoring system. I've seen many companies try, and it's great, they tried, but then they failed, and it wasn't good. So I like to think of this activity as, your network is a crime scene, and as a network engineer, you're the detective. And the idea is build yourself these capabilities to get the information off your network in a reliable way that allows you to analyze it yourself. If you don't have these complex products, you are that complex product. Like, everything is in your head, and you're the detective taking all this information, and you're trying to synthesize it in a way that you can say, it's not the network's fault, or it is. Does that make sense to you guys? All right. So now I'm going to talk about Jupyter Notebooks, because everybody says, we have an API, learn Python, That's like saying how to draw an owl. First you draw 2 circles, and then you draw the rest of the owl, right? It's just, it doesn't work that way. And one of the things that I learned very early on with the Junos PyZ stuff was I would always demonstrate it in what is called the Python interpreter, which is like a CLI. You know, you can type in some stuff and you see some stuff, and you type in some stuff and you can see some stuff. And people saw what I was doing and they said, hey, it kind of feels like a CLI. This is pretty cool. I'm not writing a program. Jupyter Notebooks takes this to the next level. And what Jupyter Notebooks are, I'll skip this. This is like how you install it. It takes 5 minutes. It runs on your laptop. And you get a web page and you can launch some stuff. I'm going to do this in the demo. But what it presents is an interface that allows you to type in text or pictures or snippets of code, and you can run them piece by piece. And if it blows up, you can go back and fix it, and you can try it again. And it has built-in help, and it has tab completion, just like a CLI. So what I learned with working with network engineers is they like a CLI experience. So this gives you a CLI-like experience. And it allows you to do something that you're doing today, which is take any method and procedure document that you already have written down, and you can literally transcribe it into Jupyter Notebooks and then automate only the little pieces that you want to automate. And maybe the other pieces you don't, because you don't have to automate all the things. You only want to automate the things that are going to increase reliability, you know, because you don't want to do repetitive tasks. Does that make sense? All right, so we're going to do a demo. This is the demo part. So there's a tool called Jupyter, and you say notebook, and I'm going to run it in the background. Okay, so what this did is, I'll make this bigger. So what this did is it popped up this window, and I'm going to click on my notebooks. And a notebook is simply just a text file. You can check it in, you can version control it. If you looked at it in a raw editor, it just looks like JSON. But when you bring it up, this looks pretty good. When you bring it up, what you'll have, you know, it'll produce a table of contents for you, and it will show you essentially the content of your Jupyter Notebook. And so if I double click in a cell, this is just markup. Like, so I can just type in any kind of text, like you can see here, and I can hit Shift Enter, and that will execute that cell. So this picture that you see here, this is basically just markup saying, you know, load this PNG file that I captured. Okay? So if you're looking at Python code, what you'll see is some of these cells allow you to enter Python code, and you can execute it. Okay? And when you execute it, you'll see a little number here. So this is a Jupyter Notebook that I have already run. And the purpose, I'll tell you the purpose of the story, and then we'll get into it. Let's say that you're working at a zoo, and this is your network. I've just made up fictitious animal name boxes with fictitious ports, and you've drawn the Visio diagram or whatever. Now, let's say that you've captured in a CSV file, you know, the LLDP relationships. And what you want to do is you want to take that data and you want this picture to be automatically drawn for you, right? Wouldn't that be great? I mean, the last time I did this presentation, they asked me to make this demo, so I'm assuming that this would be great. And the way you can look at this picture and read it and think, and this is kind of what goes back to the data modeling thing we heard in the last session. Think about it this way. Dog port 3 is connected to cat port 2 from this picture. So the blue boxes represent the devices, the brown boxes represent the interfaces, and the little circle represents the link in between. That's obviously a piece of meta. This is part of a meta model, meaning there isn't really a physical link other than, like, say, the cable. And let's say that the CSV file looks like this, right? Very simple looking file. Now, the idea here is I could literally click a button and run this notebook, and at the end of it, I expect to see a picture. So while I'm going through this, you can see that there's a little bit of code in here, and this is not going to be a code walkthrough. I'm just showing you that there's real code here. And you can mix in, you know, running some code and seeing some output and having somebody explain the process. So if you have a MOP, if you have a network engineering MOP, it says, okay, add a VLAN to this interface, and that's what they're supposed to do. And then there's a little piece of code that actually remotely logs in. Maybe it's using Yank, you know, to change the interface stat, and you run it and it says, okay, that was done. Now you go to the next thing, right? And maybe you say, okay, well, show the status of interfaces. And then there's a little piece of code to do that. You can step through this process. So there's some techniques of Python in here that are very handy, like creating a two-way map. But as a result of this, we can see what the code is doing. I can see that I created this little table that has my cabling information that says, well, what is APE port 1 connected to? It says, well, APE port 1 is connected to bare port 2. So I'm looking at the data structures of my program as I'm going along to make sure that when I'm writing this, it's actually correct. And at the end, I'm running a thing to say, make me a diagram. And in this case, I'm using this technology from the science community called Matplotlib, which they use to do all of their science pictures and graphs. And there's another piece of software called NetworkX, which is a graph and analytics and computation tool. And what I'm using it for is to do that layout automatically for me. I'm saying, here's a graph of data, and I want you to use a layout called spring layout to make the little things spread out automatically, because I don't want to lay it out. And so the rest of this is just loading data into the graph. And at the end, there says draw. And here, this is basically saying, well, I want certain shapes and sizes to look a specific way. Maybe I want the interfaces to be tan, and I want the host to be blue. And at the end, this will execute and produce, hopefully, this picture. Now, let's do the demo part, because I explained what this is doing. And so what I can do is I can reset the output. I can say restart and clear output. So imagine that you have a new data file, and now you want to rerun this notebook. So what you can see here is that these numbers are blank. This means that it has not been executed. And if I scroll all the way to the bottom, we can see that there is no picture. Okay? Now if I say cell run all, this is going to run all of the cells from top to bottom, and you can see it's kind of executing through this. And at the end, you can see I got a graph, right? And if I wanted to play with the colors, I could play with the colors. If I wanted to change the layout, because right now I'm using something called spectral layout, and this NetworkX tool has something called spring layout. And if I wanted to see what spring layout would look like, I just changed one line of code, I re-execute that cell, and now I can see what the spring layout looked like, because maybe I was just curious. I wanted to see what that looked like. And maybe I want to tweak the numbers to see and move things around. This is just an example to show you the interactive nature of this tool, Jupyter Notebooks, right? So my thesis is that if you're a network engineer and you have MOPs, that you could take any MOP and convert it into some form of execution to increase reliability into the process. Do you guys think does this hold water with you? Do you guys think that this is something that people could do, that you could do, even if you're not a Python programmer? Like if somebody gave you a recipe, you could run it, and if you already have that recipe, if somebody taught you how to convert that recipe into a Jupyter Notebook, would you want to do that? Show of hands, you want to do that. You think this would make your network more reliable, right? Not just because you think it's fun. I mean, it is fun, but that's me. So. All right. Anybody who wants to see this in more detail, see me afterwards. I'll be around. But this is the end of the demo. Unless you guys had any specific questions about Python code, I'm happy to talk Python until your ears fall off. But now I'm going to go back to the rest of the slides. Yes, yeah. It was actually developed for this purpose because scientists collaborate on their data and their experiments. So this is actually the reason why it was developed. Now, there are a million little plugins that are built for Jupyter Notebooks that have pop-up dialogues and create dashboards and all these slider visualizations. There's so much work that has been done because data scientists and that engineering discipline, they're not Python programmers, but they simply want to harness the language to achieve a result. So we don't have to reinvent any of this stuff. They're literally continuously building this technology. All right, so that's Jupyter Notebooks. I think it's pretty cool. I did the live demo. All right, where do we go from here? So let's say that you haven't even started playing with Python, you want to. What I would consider novice topics are on this list. Now, I'll talk about how you should learn them in a minute, but you can see that this list is, not small, but not terribly large. You can become fairly good at being a novice Python, become novicely aware of Python within a week. You're all really, really smart people. I believe you can do that thing. I listed the things that I think are important for the use cases that I've built over time with network engineers. These are all the libraries that you're going to need to learn. You'll get these slides, guys. Now, every single one of these libraries is its own thing. You need to learn how to do this. Has anybody used Napalm, for example? Like Napalm's great. I could write a Jupyter notebook that uses Napalm to like touch a bunch of devices. Oh, all right, good. But there's all these libraries. These are the libraries that I use the most when I'm doing network automation tasks. And you can see that there's a lot of them here. And the more you use them in the context of a recipe, the more proficient you will get, or the more competent you will be at using them, until you can understand why you would want to use a bidirectional, hash dictionary, yak, yak, yak. So if you're getting started, this is what I would suggest as next steps. Take a formal Python class, like from Global Knowledge or one of these online places. You can do it in a week. It's a fixed cost. You can get tested. You can get certified, make your company pay for it. I mean, if they want you to do this thing, they should pay for this training. Do not do it by yourself. Not because you can't, but I mean, I'm speaking for myself. I need the discipline and motivation to attend a class and get it done. Otherwise, I'll get distracted and then I won't do it. There are some really good Python newsletters. Everything's free. The two that I really, really like is from a guy named Dan Bader and then pythonweekly.com. I read these things every day, these news feeds every day. I'm a Python developer. This is my world. Download a real IDE editor. Do not write Python code in Notebook or VI. Please don't do it. Just please. Get a real editor. It's free. You can play with, PyCharm. You can get it for free. They have a commercial or a professional version. It's not expensive, but trust me, start there. Now, when you're starting to build competency, like once you have your core novice skills, and you're trying to build competency, you have to use Python every day. Just like you're on the CLI every day, just start moving your rhythm of business to, well, can I do this in a Jupyter notebook? Can I run this command kind of thing? Use Jupyter notebooks, and then do take industry classes. There's a lot of really smart people really focused on this problem space. Yvonne Pepignac at IP Space offers a lot of really good classes. Network to Code offers a lot of good classes, and Kirk Byers, he runs both a free and a paid version. These are all really smart people. They're super passionate about this space. They'll offer you knowledge in various tools and technologies like Ansible and Salt and whatnot. And then a book just came out that is highly recommended. Matt Oswald and Jason Edelman and Scott Woe, really smart guys, poured a lot of time and energy in it, support the community, buy their books. I can't say that, but I just did. I think it's a great book, actually, and it'll really help out. So with that, one of my good friends, who is also just back at Juniper, Derek Winkworth, when I had him review this is what he told me about network engineers. He said, network engineers are proficient at quickly becoming competent. And I get that. Like if you're a master route switch person and you need to know a little bit of load balancing or firewall, you can pick it up really, really fast. So I believe that you guys can be competent in Python at a really good clip. But be patient, set realistic goals. Just remember how long it took you to become a senior network engineer. I mean, it's all about setting realistic goals and having a community to work with and get feedback and help from. So that's my shtick. This is who I am. You're welcome to ask me anything. I have no idea how much time I have or if I went over. I'm sorry. But I got 1 minute? Wow. All right. I'm happy to answer any questions, or I'll be around for a while. So any questions? Is everybody going to go home and try Jupyter Notebook? Yeah. Say yes. Yes. All right. Good. I will help you. All right. Thank you. That's my show.